Section 11.2, we're looking at areas of circles and sectors. Our essential question, how can you find area of a sector of a circle? Area of a circle, which you're probably familiar with, is pi r squared, where r is our radius. So example 1, find the exact area of the circle with a given radius or diameter, then find the area to the nearest hundredth. So example 1, we have a diameter of 9, so the first thing is to say our radius is 4.5. So then pi, our radius squared. 4.5 squared is 20.25. And then 20.25 pi would be our exact area. We would leave that in terms of pi. The approximate, we're going to have as, when we multiply that out, 63.62 centimeters squared. And do remember, you're using 3.14 and pi are going to get you different answers if you plug those in. So do watch that. And if you're getting a different answer, that could, if that's close, that could be the difference as we're going through here. Then example 2 asks us to find the radius. So we have 154 feet squared equals pi r squared. So we're going to divide by pi. That will get us 49.02 equals r squared. And then my radius is going to be 7 feet. And realize when you're doing this, especially if you're doing it to like the nearest hundredth, if you get something like 49.02, even if you take the square root of that in your calculator, it's going to make the decimal so much smaller that even rounding, you're still going to round to 7 feet. So most times, if it's that close to a perfect square, you're good just going with the perfect square. Watch the directions, but normally you're good just saying, oh, I know the square root of 49 is 7, so I'm just going to say 7. Example 3. Contractor needs to cut a section out of a rectangular piece of wood as shown to the nearest square inch. What is the area of the remaining wood? Right, so first, we want to know the area of the whole rectangle. Right, so we have 11 by 7. That is our rectangle. Then we want to take out the different parts. So we need to do this in 2 sections. First, we're going to take out this square. This is 3 inches. This is 3 inches. So we're subtracting 3 times 3. And then we're taking out half a circle, which again is related to our next thing, area of a sector. This has a diameter of 3, so has a radius of 1.5, and it is half a circle. So I'm going to do 1/2 pi 1.5 squared. So I have 77 minus 9. And I get 2.25 here times 1/2 times pi. I have 3.53. So when I do 77 minus 9 and then subtract 3.53, I get 64.47 inches squared. Realize if they asked for an exact answer here, you would do 77 minus 9, which would get you 68. And then minus half of 2.25, be 1.125 pi. All right, but here they don't ask for it, and that probably makes more sense to most of us, so we'll leave it like that. Area of a sector, very similar to what we looked at in section 11.1 with arc length. We have 2 different ways of solving this. We can use the ratio or use the formula, right? Definition says the ratio of the area of the sector of a circle to the area of the whole circle, pi r squared, is equal to the ratio of the measures of the intercepted arcs. I don't think I said this in the last thing. If we're talking about what this means, right? The degrees over 360 is the fraction of the circle that I'm looking at. So this area here is the fraction of the area that I'm looking at. So when I set them equal, what I'm doing is I'm saying, okay, I know how much of the circle I'm looking at, or what percent of the circle I'm looking at, even though it isn't out of 100. So then I know I can find that area, and that's really how this works. And again, similar to what I said with the arc length, I'm going to use the ratio, because then I don't need to worry about where I'm plugging things in. I'm just cross multiplying. All right. And the weird camera thing there was me tripping. So example 4 says find the area of the sectors formed by RQS. Okay. So in example 4, we're actually doing two things, because whenever you have a sector here, you have two parts. You have in this case, you have the small part that's shaded in, and you have the large part that's white. Most times we're looking at these, we'll just find one part of that. Here it's asking us to find the area of both. So we're looking for the sector. That's x. My area is pi r squared, so 5 squared, equals my degrees, 63, over 360. Cross multiply, we get 360x equals 4,948. Divide that by 360, and I get x equals 13.74. You would also reduce the fraction here. If I reduce this to 7, this would reduce to 7 over 40. That makes this number a little bit smaller. Actually, would make this number a little bit smaller too. So sometimes the math is easier there. If you're not dealing with a calculator, you might want to consider looking at whether it reduces. Then we're looking at the large sector. All right, so I want to call that y. All right, my area is still pi 5 squared. My total circle is still 360. But now my degrees here isn't just 63, it's everything over here, which is 360 minus 63, which is 247. So again, I cross multiply. I have 360y equals 23,326.33. Divide by the 360, we get 64. Can't read my own writing. 64.80. All right, and both of those are, do they give us, they don't give us units here, so we'll just leave it without units. Normally my units here would be squared because I am looking at area. Also realize with this, here we're looking at the full circle. If we do pi 5 squared, which we didn't really look at down here because we were multiplying, I get 78.54. If I add these together, I also get 78.54 because this is the whole circle. So another way to think about this, if I found this one, I could find the area, subtract that, and get this. That would be another way to do that on these problems, if they're asking you for both. Example 5, use a diagram to find the area of the circle. So they give me this 22 meters squared is the area of the sector. That goes up top. Okay. Now, I don't want to put pi r squared here because people end up solving for r. So I'm going to put a here. And then I have 45 over 360. Cross multiply, we get 45A equals 7,920. Divide by 45, and I got 176 meters squared as my area. Okay. You want to, there's ways you could check your answer. If you want to do something really quick, if I look at 45 over 360, that's, what's that? Close to an eighth, right? If I do 8 times 22, I should be close to 176. 8 times 20 is 160, so that makes sense, right? So actually 45 over 360 is an eighth. It's not close to an eighth, it is an eighth, all right? So 8 times 22 would get me this. That makes sense. And even if you don't know exactly what it is, you could estimate like that and see. That is a reasonable area for a circle based on what they gave us. Example 6, use a diagram to find the radius of circle L. So I have 29 feet. This should be squared here. All right, we're presuming that's the arc, the area of the sector, not the arc length. 29 feet. Now here I'm going to write pi r squared because I'm looking for the radius. My degrees is 65. Right, and over 360. So 360 times 29 is going to get me 10,440. 65 times pi is 204.20 r squared. And you could leave this in terms of pi, but we're going to end up doing square root. That gets really messy. So generally that would be a pain here, but if you're asked to do it, you can. Divide by 204.20, I get 51.13 is equal to my radius squared. So my radius, I take the square root of that. I got 7.15 feet. Okay. Then at the end here, we'll look at population density, because this is where the book throws it in. Population density is how many people live within a given square area. So we do number of people over the area of the land. So we have a town of Manchester, 50,000 people, shape of a rectangle, 5 miles wide and 7 miles long. Now, in actuality, these are never this nice because you never have like the town that's actually a circle or actually a rectangle, but makes our life easier for right now. What's the population of the people in square miles? So I have 50,000 people over my area, 5 times 7, right, gives me 50,000 over 35, which gives me 1,428.57 people per square mile. Then B, they decide to make our life a little bit more difficult. All right, they say the town contains a business area in the center of town that is the shape of a disc, also known as a circle, with a radius of 1 mile. No one resides in the business area, right? So what is the population of density in Manchester in people per square mile in the non-business district? So what's going to change here is our area. Instead of having 35, we're going to subtract that circle. All right, now they make it nice. They tell us I have a radius of 1 mile, right? So I'm doing 1 squared times pi. 1 squared is 1. So I'm just going to subtract 3.14 here, which gives me 31.86. That changes my fraction. So now I have 1,569.37 people per square mile, which makes sense. Area went down, population stayed the same, population density should increase.